This is a one-stop video on the topic carbon and its compounds. To understand this chapter, class 10th chemistry, to understand this chapter, we should have a good information about the periodic classification of elements. Let's see where carbon is. Carbon is in this location where I'm putting an outline. So carbon has an atomic number of 6. So basically the stable form of carbon is carbon 12-6. Though other isotopes, carbon 13-6, carbon 14-6 are also there, carbon 12-6. 6 means configuration 2 and 4. So first we understand what is 12. 12 is a mass number. Mass number means number of protons and number of neutrons. 6 means number of electrons. Whatever is the number of electrons, that means number of protons will be. So here in carbon there are 6 protons and there are 6 electrons and there are 6 neutrons. So 6 electrons are well held by 6 protons. Now coming to configuration. Electronic configuration is a 2 and 4. Means carbon's nucleus. Nucleus of carbon has 6 protons and 6 neutrons. This is tightly packed inside the nucleus. And then the first orbit where there are 2 electrons. And the second orbit which has got 4 electrons. So innermost orbit which has got 2 electrons is completely filled. But the second orbit which has got 4 electrons is semi-filled, because second orbit should have 8 electrons for carbon to reach its noble gas configuration. So either the outermost orbit should get 4 electrons so that carbon reaches, like you see here, carbon's electronic configuration 2 and 4. So 2, 8, 8, 18, like that. That's how the electronic configuration of any atom should be. But it is 2 and 4. So it needs a 4 electron. So either it should take a 4 electron so that the outermost orbit is filled. But if it takes 4 electron, then carbon will have totally 4 plus 4 plus 2. That means 10 electrons. So 6 protons cannot be balanced by 10 electrons if carbon takes 4 electrons. So if carbon takes 4 electrons to reach the noble gas, so it becomes a neon if it takes 4 electrons. Then since it can't take, because the balance is disturbed, it should give away the 4 electrons. So for giving away means what? To remove the first electron, lot amount of ionization energy is needed to pull it out. Why? Because the second orbit, 4, second orbit means which is very close to the nucleus. They are well held by the 6 protons tightly, the electrostatic attraction. If the first electron, by putting some ionization energy, we remove it, then the atomic radius shrinks. Outermost orbit comes closer to the nucleus. Then the second electron, third electron and the fourth electron are tightly held by the 6 protons. And then if we remove the next electron by putting a little more amount of ionization energy, then it becomes way too difficult to remove the third electron and the fourth electron, because by the time the second orbit will be close to the nucleus and well held by the nucleus. But if in any case we remove the 4 electrons, then what happens? 6 protons will have to hold only the innermost 2 electrons. Then also the balance is lost. So carbon has the difficulty that it can neither take 4 electrons to reach the noble gas neon, or it can leave the 4 electrons to reach the nearest noble gas, that is helium. So carbon has a difficulty of leaving 4 electrons. If it loses 4 electrons, it will come under the category of metals. That means left of carbon, these all are metals. If it takes 4 electrons, then it becomes a non-metal. So the right side is all non-metals. So carbon is neither a metal nor a non-metal, because it has got that 4 electrons in the outermost. It has the difficulty of either taking 4 or leaving 4. It can't do any of them. But still carbon is a non-metal. That is why this chapter is special, because carbon is neither giving 4 electrons nor taking 4 electrons. Instead, it is a sharing its 4 outermost electrons with other atoms so that it can form a covalent compound. And hence this chapter, carbon and its compound, because it's sharing. And when we share, we have many friends. That's why carbon has so many friends. And that's the whole story of organic chemistry. So now starting with what are organic compounds? Compounds that contain carbon essentially and hydrogen mostly. Other than there is oxygen, sulfur, nitrogen, halogen, etc. Those are all organic compounds, naturally occurring compounds. What is a chemical bond? Force of attraction that holds the two atoms together is a chemical bond. So there are two types of chemical bond, ionic bond and covalent bond. Then coming to ionic compounds properties, because the last chapter we ended with ionic compounds, and now in this chapter we are starting with covalent compounds. So first we revise what is ionic compound, then we'll deep dive into the covalent compounds. What are the properties of ionic compounds? Ionic compounds means when um, uh, metals give electrons and non-metals take electrons. So when a bond is formed by giving and taking, not sharing, such compounds are ionic compounds. Example, sodium, Na plus, Cl minus. So sodium gives one electron and chloride ion takes one electron, becomes chlorine, and you get sodium chloride. That's an ionic compound. So ionic compounds, physical nature. All ionic compounds are solid. All ionic compounds are solid. Uh, okay. So we can say brittle because if you hammer them, they will get powdered. They will become powder. All ionic compounds melting point is high. So boiling point is also high. Why? Why? Because ionic compounds are held by electrostatic forces. Electrostatic forces. Ionic compounds are held by electrostatic forces. So that's why the melting point is high, and finally boiling point is also high. Solubility, all ionic compounds means electrovalent compounds are soluble in water and insoluble in organic solvents. Organic solvents. What are all organic solvents? Organic solvents are like kerosene or petrol or benzene, if we name some chemical compounds. Benzene, toluene, these are ring structures, unsaturated ring structures, toluene, etc. So ionic compounds are soluble in water, means polar solvents. Ionic compounds are soluble in polar solvents and insoluble in organic solvents. About conductivity, conduction to electricity, ionic compounds are best conductor of electricity, but they do not conduct electricity when they are in solid state. So ionic compounds in solid state do not conduct electricity, but when they are in molten form, they conduct electricity in molten form and in aqueous solution and in aqueous solutions of those salts. Then they conduct electricity. That was about ionic compounds. Now, this is an important point. Compounds formed by transfer of electrons from metals to non-metals, they are ionic compounds. But compounds that are formed by equal sharing of electrons between atoms of elements, they are covalent compounds. So this is the one line definition difference between ionic compounds and covalent compounds. So these are the three isotopes of carbon, in which the first one, carbon 12-6, is the stable state. Carbon 13 state is not naturally occurring. Carbon 14-6 is special. This is used for carbon dating. Carbon dating means to find age of fossils. How much amount of carbon 14 element is left in that fossil tells its age. Now coming to electron dot structure, otherwise known as Lewis dot structure. So we'll start with hydrogen molecule. So hydrogen molecule, how does hydrogen molecule look like? So hydrogen is a monovalent. So hydrogen and another hydrogen. So hydrogen monovalent. So one electron, outermost valence electron, they share with each other, and like this a covalent compound is formed. Remember, metal plus non-metal is ionic compound, but non-metal plus non-metal is always covalent compound. Non-metals always form bonds by sharing, and metals and non-metal is like a give and a take. Okay. Chlorine molecule, chlorine is a 17. 17 means what? 2, 8, 7. So 1, 2, 3, 4, 5, 6 and 7. The other chlorine 1, 2, 3, 4, 5, 6 and 7. So both the chloride ions share 1 electron each, and hence they reach their noble gas configuration. So both of them are getting 8 each. So you get a diatomic molecule Cl2. Coming to hydrogen fluoride. Hydrogen is monovalent. Fluoride has hydrogen is monovalent, and fluorine is has 7 valency. Valency is 7. So hydrogen 1 and fluorine F has 1, 2, 3, 4, 5, 6 and 7. So like this, 1 electron, equal sharing of electrons whenever it happens, and then there is a covalent bond. So hydrogen fluoride. Water molecule. So this electron dot structure is very important from examination point of view. So there is a hydrogen, 1 valency, and there is oxygen which has got 6 valency. So 1, 2, 3, 4, 5 and 6, and the other side 1 more hydrogen. So hydrogen is sharing 1 electron with oxygen. Hydrogen is sharing 1 electron with oxygen. So hydrogen reached its octet, means hydrogen reached the helium gas configuration. Oxygen took 2 electrons from the 2 hydrogen and it reached its nearest gas configuration, that is 8. That means oxygen reached neon, and hence we have H2O. Moving forward, ammonia. Nitrogen is pentavalent. Nitrogen is pentavalent. Hydrogen is monovalent. So here nitrogen and H3. So H, H and H. So hydrogen's 1, hydrogen's 1 electron. This is hydrogen's 1 electron. Nitrogen is pentavalent. So it's 1, 2, 3. This is 4 and 5. That means that there will be a lone pair. A lone pair means an unshared pair of electrons will be. In this way, hydrogen reached its noble gas configuration. Hydrogen reached its noble gas configuration, and nitrogen also reached its noble gas configuration. In that way, NH3 is formed. About methane. So from here onwards, things are easy because you know the compound methane, CH4. So get ready with the tetravalent structure of carbon. Carbon has 4 valency. Okay, so 1 and hydrogen's 1. Carbon's 1, hydrogen's 1. Carbon's 1, hydrogen's 1, 1 of each. So hydrogen, this one, single bond. Methane means if 1 electron is shared by both the atoms, then single bond. 2 electrons shared, double bond. 3 electrons shared, triple bond. So this is CH4. Only one electron shared, that's why methane has a single bond between carbon and hydrogen. Ethane, similarly the same thing. So carbon and ethane, no? So CnH2n plus 2. So here carbon shares 1 electron with the carbon. So both the carbons have shared 1, 1. So remaining how much? 1 over 2, 3, 4. This carbon's 1 is over, so 2, 3, 4. So the other hydrogen is here, the other hydrogen is here, the other hydrogen is here, the other hydrogen is here. So these hydrogens are also sharing their, because they are monovalent, so they are sharing their single electron with the carbon. As a result, all the hydrogen reached their octet, their noble gas configuration. All of them reach their noble gas configuration. About carbon, each carbon gets 8 electrons, so carbon is also reaching its noble gas configuration, that is the neon. And this is how ethane looks like. CH3, CH3, single bond. Methyl chloride. Methyl chloride is a CH3Cl. So you can do the same thing. Similar kind of structure comes out. This is the CH3Cl. Put all the single bonds and erase the single bonds and put 2 crosses. Carbon tetrachloride is CCl4. CCl4. That means instead of CH3, remove the 3 hydrogen and put remove the 4 hydrogen and put 3 and 4 chloride. So that's carbon tetrachloride. Coming to double bond, oxygen molecule. You know that oxygen is valency is a 6. So here oxygen 1, 2, 3, 4, 5, 6. So it needs a 2 electrons to reach its noble gas configuration. If it needs 2, it has to share its 2. So it shares its 2 electron with another oxygen like this. Okay. And in this way, oxygen reached its noble gas configuration and the other oxygen also reached its noble gas configuration. In this way, there is oxygen-oxygen double bond. Means O2 is actually oxygen-oxygen double bond. What about ethene? Ethene is a carbon-carbon double bond. Okay, so here CH2 and CH2. So this one thing I'm doing, the rest one will be easy. So carbon shares 1 electron each with hydrogen, and the remaining 2 electron it will share with the other carbon. Other carbon also shares 1 electron each with hydrogen like this. So all the hydrogens reach their noble gas configuration because they got 2 electron for themselves by sharing, and carbon gets its 8 electrons by sharing. Carbon gets its 8 electrons by sharing. So that is a carbon-carbon double bond. Coming to examination point of view, carbon dioxide. Carbon dioxide molecule, electron dot structure is very important. So it's a carbon dioxide. So 2 oxygen. Oxygen has a valency of 6, so 1, 2, 3, 4, and here 5, 6. Oxygen 1, 2, 3, 4, and 5, 6. So oxygen needs a 2 electrons. So it will take 2 electrons from the neighbor carbon. Carbon has 4. So it gave 2 electrons to one oxygen, another 2 to the other oxygen. In this way, oxygen reached its noble gas configuration. The other oxygen also reached its noble gas configuration, and thereby carbon also reached its noble gas configuration. So carbon dioxide is actually carbon double bond O as well as double bond O. So it is carbon dioxide, CO2. Coming to triple bonds, nitrogen. Nitrogen is pentavalent, so N2, pentavalent. Okay, 1, 2, 3, 4, 5. So it needs 5, no, it needs 3 electrons. How many it needs, that many it has to share. So it is ready with a 3 electron sharing that shares with the other nitrogen. So now nitrogen got its 8 electrons. This nitrogen also got its 8 electrons by sharing 3 electrons. So it is nitrogen, triple bond nitrogen, a diatomic molecule, N2. N2 is actually nitrogen, triple bond nitrogen. About ethyne. Ethyne is the alkyne, means what? Carbon, triple bond, carbon. CH, CH means C2H2. So you can share 1 electron with hydrogen each and 3 electrons shared among the carbon. Okay, so that was, you can do it. Coming to allotropy. So what is meant by allotropy? Why this topic has come? Why? Because carbon displays allotropy. Allotropy I have defined it here. Allotropy is a property due to which element can exist in more than one physical form. Okay. And example, carbon, sulfur, phosphorus, oxygen, all of them display allotropy. You know that allotropes of carbon are diamond, graphite, and carbon-60, Buckminster fullerenes. Diamond means one carbon attached to 4 carbon atoms. In that way, a drop down kind of structure comes. Graphite means graphite is a two-dimensional layered hexagonal structure. So hexagons are connected. Every carbon is connected to three other carbon and hexagonal structure of layers. That is graphite. Buckminster fullerenes is pentagons connected to hexagons. So every one pentagon is connected to 6 hexagon to form a football structure. That was about allotropy of carbon. Now coming to carbon exists in both crystalline and amorphous. What is the meaning of crystalline? Crystalline is graphite. Crystalline is a diamond. Crystalline is a diamond. And amorphous. Amorphous means a charcoal. Charcoal, coke. These are amorphous forms of carbon. Amorphous forms of carbon. Okay, just a moment. Okay. So they are the amorphous forms of carbon. Yeah. So what are the allotropes of carbon? Allotropes of carbon is, so when you see carbon's structure like this, okay, and something of this kind when you see, this is about diamond structure. Okay, so this is a diamond, an allotrope of carbon. So what is the meaning of allotropes of carbon? Different physical forms, but same or similar chemical properties, because all of them are carbon. Okay, so graphite, how does this allotrope looks like? Graphite is a layered 2D figure, like hexagons. So these junctions, you have carbon. This is a carbon, 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 hexagons, single bonds. And then this is how it looks. Okay, this is how it looks. So it will be layered. So these are connected, loosely connected. Okay, so bonds are weak. That's why graphite is kind of porous, but crystalline. Okay, so here this again, you have the hexagonal structures connected to each other, something like this. Okay, so this is how graphite looks like. About Buckminster fullerenes, that is discovered by Buckminster fullerenes. That is carbon 60. There are 60 carbon atoms in that. Here, every pentagonal structure, that means on that vertices, on the vertices you have the carbon atom. So these are carbon atom locations. So every pentagon is connected to hexagons, and like that these structures are made. So this, unless pentagon is connected to hexagon, the folding of football will not come. So if we want the folding of football to come, we have to have the pentagon connected to hexagon, further hexagon connected to pentagons. It should be like that. So like this. Like this. So this needs a folding and you get a football structure. So football. So next time you go to the football, you go to the sports room, you see football. Football is made up of pentagons connected to hexagons, hexagons connected to pentagons. Coming to catenation. What is catenation? Catenation is a special property that carbon compounds display. It is a property, so catenation is a property due to which an atom, so here I wrote carbon atom, but any atom can form bonds with other atoms of itself. So it's a property due to which carbon atoms form bonds with other atoms of carbon. Carbon can show this property to the maximum extent. Why? Because carbon size is small, because it has got only 2 orbits. So the final orbit, which has got the valence electron, which form bond with the other carbon atom's valence electron, they are very close to the nucleus. So the bonds are very strong between carbon and carbon. That is why carbon can self-link to similar kind of itself, of its own atoms, and form long chains of carbon atoms thereby giving large compounds of carbon. So this carbon can do, but who else can do catenation? Catenation is also displayed by silicon and germanium. But silicon has a 3 orbits. So the silicon-silicon catenation will go up to hardly 7 or 8 atoms of silicon, and then it will not form. Long chains of silicon is not possible, but they do catenation because third outermost orbit, the valence electrons are in the third orbit. So third orbit is far away from the nucleus, so bonds between silicon-silicon may not be that strong as seen in case of carbon. Germanium also does catenation, but hardly 4 to 5 germanium atoms can self-link to form, a bit bigger compounds, of course, compared to other. So catenation is a property where self-linking is done between atoms, especially carbon atom, and carbon-carbon bond is always stronger because bond length is small. That is catenation. Coming to what are hydrocarbons and how do you classify them? Hydrocarbons means all the compounds which contain hydrogen and carbon. How do you classify them? You classify them as saturated hydrocarbons and saturated hydrocarbons or unsaturated hydrocarbons. Okay, so hydrocarbons are basically compounds which contain basically carbon and hydrogen. We classify them as saturated, unsaturated. We can have this classification also like straight chain hydrocarbons, straight chain hydrocarbons, ring structured hydrocarbons. Here, ring structure means we come across a cyclopentane, cyclohexane, single bonds between carbon and carbon, but cyclic. And then aromatic hydrocarbons. Aromatic hydrocarbons means ring structure, but there will be single bond or double bond sometimes between the carbon atoms. Example, benzene. So, this is how we classify them. So basically we classify them as saturated, unsaturated. So saturated are all alkanes with general formula CnH2n plus 2. Unsaturated are basically alkenes and alkynes. What are alkenes? Alkenes are the carbon compounds with general formula CnH2n. Alkynes are those hydrocarbons with general formula CnH2n minus 2. So this is how we classify hydrocarbons. This chapter is basically about this. Differentiate between saturated and unsaturated hydrocarbon. Just to remember what are saturated hydrocarbons, methane, ethane, propane, butane, these all are saturated hydrocarbons where carbon and hydrogen or between carbon and carbon there is single bond. Unsaturated hydrocarbons are the camphor and the mothball, those all, they are unsaturated where between carbon and carbon there may be double bond or triple bond. Single bond are saturated, double bond and triple bond are unsaturated. So how do you differentiate? So for difference, I'm just having the side heading. So this is saturated hydrocarbons, and then we have unsaturated hydrocarbons. So here, first point, between carbon and carbon, there will be single bond. Unsaturated hydrocarbon, between carbon-carbon, there may be a double bond or there may be a triple bond. So you can frame that into sentence. I'm just writing in points. Next, saturated hydrocarbons burn with blue flame. They burn with blue flame in air. Blue flame. That means they undergo complete combustion when exposed to air. Though air has oxygen percentage very less, 21% of air is oxygen. But they undergo complete combustion and they give blue flame. But unsaturated hydrocarbon in air, they undergo incomplete combustion. So they burn with sooty flame. They burn with sooty flame in air. flame in air. So if we want complete combustion of unsaturated hydrocarbons to occur, we have to supply oxygen, not air. We have to supply pure oxygen. That is why we have an example like why ethane plus oxygen is used for welding purpose. Why? Because ethane is unsaturated hydrocarbon. Unsaturated hydrocarbon in presence of air, they burn with sooty flame. And if soot is there, means carbon deposits, means unburned carbon particles are there, that may not produce that much amount of heat energy that is needed to combine metals, means welding. So ethane has to be burnt in presence of oxygen so that complete combustion occurs. That gives a blue flame. And remember, whenever blue flame comes, the blue part of the flame has got the highest temperature. That will be sufficient to do the welding. So that is the important difference between saturated and unsaturated hydrocarbons. The next third point, saturated hydrocarbons have no reaction with bromine water. This is the test of saturated or unsaturated hydrocarbon. Unsaturated hydrocarbons, whereas unsaturated hydrocarbons decolorize. Unsaturated hydrocarbons decolorize bromine water, means they react with bromine water. So here I prefer to write the equations of how unsaturated hydrocarbon does the decolorization, why it does. Saturated hydrocarbon do not react with bromine at all. Okay, so about decolorization, unsaturated hydrocarbons. So example, this is ethene. Ethene plus bromine water gives CH2, attach a Br here, attach a bromine here. This is called, you can just form the compound structure. I just do that so that we can do the IUPAC name of this. The double bond is broken, single bond. Then you have H, Here also you had H, earlier also you had H. So one of the bond breaks and that helps to connect the Br2. What is the name of the compound? It is 1, 2. I'm just numbering the carbon atoms. So it is 1, 2 dibromo, because the two bromide ions are connected. No? So dibromo ethane, because now it is saturated. You see all single bonds. Then I will write the reaction when this is ethene, reaction with bromine water. How about this is example 1. How about example 2? When ethine, unsaturated hydrocarbon, reacts with bromine water, Br2. This forms Br2 CHCH Br2, and its name is 1122. That means one bromide in this direction, one bromide in this direction, and one hydrogen. So that's why numbering, if you do 1 1, and here this carbon gets a second number. So that's why 1122, 1122 dibromo ethane. So 1122 dibromo ethane. I'm sorry, it's not di, because 4 bromide ions are there. So tetrabromo ethane. It's tetrabromo ethane. I hope this is very helpful to you. Ethane, E-T-H-A-N-E. So unsaturated becomes saturated. And they decolorize bromine water. Bromine water has a brown color, that gets decolorized. So bromine doesn't look as bromine anymore. Coming to what are functional groups. What are functional groups? Functional groups are, functional group. What are functional groups? It is an atom or a group of atoms which largely determines the chemical properties of that compound. So what can be the examples of functional group? Examples of functional groups are alkanes. All alkanes have the functional group of single bond. Alkenes have the functional group of double bond. Alkynes have the functional group of triple bond. Then there is hydroxyl group. There is carbonyl group. Carbonyl means what? CHO as well as CO. Then there is haloalkanes. Then there is ester. And there is carboxylic acid, COOH. So these are the examples of functional group. The functional group, those atoms, they determine whether it is alcohol, whether it is aldehyde or ketone or ester. So functional group is an atom or group of atoms which largely determines the chemical properties of the compound. Coming to homologous series. What are homologous series? These are a series of compounds that are derived from the same general formula, like alkanes CnH2n plus 2, alkanes CnH2n, alkynes CnH2n minus 2, alcohol CnH2n plus 1 OH, like that. So these are the compounds that are derived from the same general formula having same functional group. That is, all of them are either alkanes or alkenes or alcohols or aldehydes, etc. Similar chemical properties, but show gradation in physical properties. Means as we move to the next compound, the number of carbon atoms may increase, number of hydrogen atom may also increase. The the functional group that is attached, that may remain same. So each member differs from the successive member by CH2 molecule and an atomic mass of 14. Because the CH2 is what? Carbon is 12 plus hydrogen atomic number 1 into 2. So 12 plus 1 into 2, that is 14. So every successive atomic compound's atomic number varies with 14 atomic mass unit. For example, alkanes, first member is CH4, second member is C2H6. So the difference of this is what? C2 minus C means what? H6 minus H4. H6 minus H4 is H2. So this is a methane and this one is ethane. So the same difference will be with the next compound and ethane. Means propane minus ethane is also CH2. And every successive compound will have an atomic mass variation of 14 atomic mass unit. Coming to IUPAC names. General formula for saturated hydrocarbons means alkanes is a CnH2n plus 2. Unsaturated hydrocarbons means alkene. Alkene is CnH2n. Alkyne. Alkyne is CnH2n minus 2. So these are the general formulas. That is, in place of n, when you put the natural number 1, you get the first element or first compound. In place of n, if you put 2, you get the second, like that. Coming to IUPAC. What is the expansion or abbreviation for IUPAC? International Unit of Pure and Applied Chemistry. Nomenclature types. How do you do the naming? Now this one is an alkane. So we have to see this additional alkyl group. CH3 is the alkyl group. Is attached to which numbered carbon? So left to right, right to left, you count. This attachment comes to the third carbon. So we'll number like this: 1, 2, 3, 4, 5. If you number from right to left, then also third carbon. So at third carbon, you have the alkyl group, right? So you can call this IUPAC name is 3-methyl pentane. Ane, why? Because all single bonds. Pent because there are 5 carbon atoms in one line. 3-methyl because at the third carbon there is a methyl group added. Coming to the next one, what could be the name of this? You see, we have to number such that the functional group gets the lowest, functional group holding carbon atom gets the lowest number. So here functional group is a double bond. 1, 2, 3, 4. So you can name it as a 1-ene. Okay, there are two ways of naming. So you can 1-ene, 2. Here, this is ethyl. So 2-ethyl, and 4 carbon atoms in one line. So you can call it as butane, or we can call it as a 2-ethyl butene. 2-ethyl butene. Oh, we can do this. 2-ethyl 1-butene. 2-ethyl 1-butene. You can do this. Okay. So that's how we do the IUPAC naming of the atom. Let's move on further. So number of carbon atoms, prefix is meth for 1 carbon, eth for 2 carbon, prop, but. Okay, so like that 3, 4, 5 like that. Functional group is always the suffix. So here, how do you name this? Very simple. It's 2-methyl butane. This is 2,2-dimethyl propane. You see 1, 2, 3. 3 carbon atoms in one line. So propane. And at the second carbon, there are 2 methyl groups. That's why 2, 2. If you just say only 2 methyl, its meaning is 1 methane group. Similarly here, it is here this connection, and it is this connection. So it's a 1, 2, 3, 4. It is a 2, 3, dimethyl butane. That's it. Here this one is 1, 2, 3, 4. It is a 2. 1, 2, 3, 4. It's a butene, 2-butene. It's an alkene group, okay, unsaturated. Let's move on. What are isomers? Isomers or isomerism is a property displayed by carbon compounds in which they have different structural formula but same molecular formula, not chemical formula, not chemical properties. It's about the formula. Their structures are different but molecular formula is same. Say for example, okay, example I'll give, but what are the types of isomers? There are 3 types of isomers. Normal means a straight chain. Normal means a straight chain, then iso, and then neo. Normal means it is a straight chain. It is a straight chain of carbon atoms. Iso meaning is 1 carbon attached to 3 other carbon. Okay, and then it may extend, that's okay. Neo means 1 carbon is attached to 4 other carbons. So whenever you see structures of this kind, you have to recognize them as isomers of a compound. Okay. Example, best example is of pentane. I suppose when we move forward, yeah, mention isomers of pentane, all 3. So I'm doing first for pentane. How does isomers of pentane look like? I try to accommodate in this space. Okay. Pentane is first normal. So 1, 2, 3, 4, 5. So 5 carbon, CH3, CH2, CH2, CH2 and CH3. Yeah, right in one line you can do this. Okay, so this is N-pentane. N-pentane. Okay, you can do this something better way like this. Okay, and just go for this H, H, H and this H. This is how it looks like. I just reduce the space of writing, but however, molecular formula is same. Structure is a straight. Straight structure means what? Normal. Normal chain pentane. Coming to isopentane. Isopentane is what? 1 carbon attached to 3 carbon atoms. Then we have 1 extra carbon also. No, totally pentane. 1, 2, 3, 4, 5. So 5. So this is CH3. This is CH2. This carbon has 3 bonds done. So a CH, and this is CH3. And this one is also CH3. So this is called isopentane. Isopentane. Pentane. What about neopentane? Neopentane is one carbon attached to four other carbon atoms. And now you see the carbon count is over. So CH3 in all four directions. CH3 in all four directions. This is called a neopentane. So these are the three structural isomers of a pentane. How about butane? Three. Will there be three structures of butane? Butene. Let's see. One, two, three, four. So one of them, two of them are normal chains only. So you have double bond here. The next one C, 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 and the double bond is here. Remaining you can fill with hydrogen. CH3, CH2, here CH, and here CH2. Here CH3, here CH, here CH, and here CH3. Both of them are normal. The first one is a 1-butene, the second is a 2-butene. The third one is one carbon attached to 3 carbon. One carbon attached to 3 carbon. So you see. But it is butene, no? So one double bond should be. You can put anywhere one of the places. The name will not change then. This is CH2 and middle carbon will not get any hydrogen, and this is CH3 and this is also CH3. So this is isobutene. Neobutene is not possible because it is butene, no 3 carbons attached to single carbon. Butane, 2 of them. Butane is again normal straight, 1, 2, 3, 4. And you can put 3 of them here, and this is H, and this is CH2, and this is CH3. 1 butene, this one, and another is 1, 2, 3, 4, and shift the triple bond somewhere other place. This is CH3, these 2 carbon atoms don't get hydrogen at all. The last one again gets CH3. So these are the 2 isomers of butane. Both of them are normal, of course. Now coming to functional groups. Alkane, alkene, alkyne. So I'm writing the general form of this. That is alkane. Alkane is what? CN, H2N plus 2. The first atom is CH4, methane. Next atom is C2, H6, that is ethane. The third is C3, H8, that is propane. Methane, ethane, propane, butane. Methane is the one that you see 2NO678, etc. So methane is the one that you see in natural gas. Butane is the one that you see in LPG gas cylinders. Alkene has a formula, general formula of CnH2n. N is natural number. So what is the first one? You see, first one, alkene has a single bonds between carbon atoms. Alkane has a single bond between carbon atoms. Okay. Alkene has a between carbon bonds and carbon and hydrogen also. Alkene has a double bond between carbon atoms. So if you take N as 1, the first compound is CH2. CH2 is that difference of molecule between homologous series. So CH2 compound is not a fully filled compound. So it is not possible. That means methane, the first carbon, the first member of the family, methane, single carbon, do not exist. So here the first compound is carbon-carbon double bond. And this is CH2 and this is CH2. So C2H4 is ethene. The first member of alkene is ethene. Otherwise, it is known as ethylene. Ethylene. What is ethylene? It is the gas that is used to ripe fruits and vegetables. Okay. Second is ethene. Then there is propene, butene, those all. But methane do not exist. So carbon-carbon single double bond should be. Alkyne general formula is CnH2n minus 2. So in this case also, the first member of the family, meth, is not there, not possible. So you have carbon-carbon triple bond. So it is a CH. So the compound, first compound is ethine. Ethine is C2H2. Ethine is C2H2. So carbon-carbon triple bond. What about alcohol structure formula? CnH2n plus 1 OH. First member of the family is CH3OH, that is a methanol. C2H5OH, it is ethanol. There is propanol, butanol, all is well. So it completes with all. So the name ends with it. This is the suffix. Prefix is based on number of carbon atoms. Carbonyl group. There are two of them, aldehyde and ketone. So carbonyl group meaning is carbon with a double bond O, and the remaining two bonds have to be taken up. So if the carbon with double bond O, one of them is alkyl group and another is a hydrogen, then this is called aldehyde. Aldehyde. The first family member of aldehyde, ALDEHYDE. Aldehyde is formaldehyde, methanol. So this ends with al suffix. The name, IUPAC names end with al. Methanol, ethanol, propanol, those all. But if the carbon double bond O, the either sides are alkyl groups only. R means some CH3. Okay, and the continuation also CH2, CH3, CH2, CH2, CH3, CH2, 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 CH3, like that. Those alkyl groups. If a terminal group, it is aldehyde. If it is not a terminal group, see C double bond O, R, R either sides, it is a ketone. It is a ketone and the IUPAC name ends with ONE, ONE. So there is no methanon, there is no ethanon. So the first family member is a propanon. Propanon. Okay, first family member of aldehyde is methanol. Methanol. Second is ethanol, those are okay. But ketones, the first two, meth, eth compounds are not there. It starts with 3 carbon atoms. That's why propanol. Coming to carboxylic acid. How does carboxylic acid look like? Carboxylic acid is the group is a C double bond O and then OH. So the other side you can put an R, alkyl group. So this is OIC. The naming is OIC. Suffix OIC, OIC. So the first family member is H, COOH. This is methanoic acid, and then it is an acid. Okay, then the second is R, can be CH3, COOH. COOH is the functional group. It is called ethanoic acid. Ethanoic acid. So methanoic acid is formic acid. That is the one that we get during bee's sting. Ethanoic acid is acetic acid. Acetic acid has many functions. Coming to haloalkanes. Halogens. What are halogens? Chloro, bromo, fluoro, iodo. These are halogens. How they look like? Like CH3Cl. It is called a chloromethane. Chloromethane or bromomethane or fluoromethane, iodomethane, like that. You can name them. Coming to this, does carbon burns in all its allotropic forms? Answer is yes, because it's still carbon. Because it's still carbon, it will burn. What are the products of combustion? Products of combustion is always carbon compound. See, carbon compound or hydrocarbon. Carbon compound or hydrocarbon compound. Combustion means what? Heating the carbon compound to its ignition temperature in presence of oxygen. It always gives carbon dioxide, water and heat energy. Heat and light energy. These are the two things that we can sense whereas all forms of energy, in fact. So it gives energy and energy. Okay, now let's do this. Now coming to combustion reaction. Always remember, combustion is heating of a combustible substance to its ignition temperature in presence of oxygen. As a result, the combustible substance burns, giving out carbon dioxide, water and energy. So always combustion reaction gives carbon dioxide, water and energy. So carbon plus oxygen means what? When coal is burnt in presence of oxygen and coal is heated to its ignition temperature. So carbon plus oxygen on heating gives carbon dioxide and energy. I'm representing energy with the letter Q from next. So methane plus oxygen. Methane is the best fuel on earth. Natural gas is 98 or 99% methane. This gives, whenever complete combustion occurs, that will give us carbon dioxide and water. Saturated hydrocarbons always undergo complete combustion and produces good amount of heat energy, high calorific value. Similarly, this carbon compound, this also, every carbon compound or combustion of everything always, hydrocarbon especially, gives carbon dioxide, water and energy. Alcohols also on burning gives carbon dioxide, water and energy. What you have to remember is, if it is a carbohydrate, if it is a hydrocarbon, in presence of oxygen on heating will give us carbon dioxide, water and energy. Energy can be in form of heat, light, etc. So see, ethanoic acid here plus oxygen on heating gives carbon dioxide, water and heat energy. That is it. So that's about combustion reaction. Remember definition of combustion reaction. Combustion reaction is heating of a hydrocarbon or a combustible object to its ignition temperature in presence of oxygen. That results in carbon dioxide, water and energy. Coming to addition reaction. What is the meaning of addition reaction? Addition reaction is a reaction in which unsaturated hydrocarbon reacts with a molecule like hydrogen, chlorine, water, etc. to form a saturated hydrocarbon. So what is addition reaction? A reaction in which unsaturated hydrocarbon or a compound reacts with a molecule like hydrogen, chloride or water, etc. to form a saturated hydrocarbons. Unsaturated to saturated by adding something, a diatomic or some other compound, is called addition reaction. The best example is vegetable oil getting converted to vegetable ghee. Here, unsaturated carbon compound is like this one, carbon-carbon double bond, and these are the alkyl groups R. What is R? R is actually the CH3 molecule. This one adds hydrogen in presence of nickel or palladium. Nickel or palladium on a little heating becomes a saturated hydrocarbon. So earlier the alkyl groups were there, so they are there, but one bond breaks and that accommodates for each carbon atom a hydrogen. So the left side, this one is a vegetable oil, and the right side is vegetable ghee, vegetable butter. So here we should know that the vegetable ghee is unhealthy and vegetable oil is healthy. So this one is unhealthy. That means unsaturated oils are unhealthy. Unsaturated carbon compounds are not good for health. What is a catalyst? Catalyst is a substance that catalyzes a reaction. That means that improves the rate of reaction and the substance itself doesn't participate. So example of catalyst is nickel or palladium or platinum or acidified potassium dichromate and alkaline potassium permanganate, etc. Coming to substitution reaction. What is substitution reaction? A reaction in which saturated hydrocarbons are least reactive, of course, and they are inert in presence of most reagents. Then saturated hydrocarbons don't react with chemicals in a way. However, saturated hydrocarbons react with chlorine in presence of sunlight, and that reaction is quite fast. Here chlorine replaces hydrogen atoms one by one, and this process is called substitution reaction. So here CH4 plus Cl2 in presence of sunlight. In presence of sunlight, first what happens? It replaces one of the hydrogen atom and becomes CH3Cl and HCl is formed. Once again, chlorine in presence of sunlight. This is step-by-step process. Becomes CH2Cl2 and again HCl. We can do the balancing, that's okay. So this is how things go on in substitution reaction. So this once again on reacting with chlorine in presence of sunlight, because for carrying out a reaction we want heat, light, electricity, like that. It becomes CHCl3. And what is ClCl3? This is chloroform. Chloroform, a low boiling point and melting point. And then further adding CCl2 in presence of sunlight. In presence of sunlight, it gives CCl4. And what it is? It is carbon tetrachloride. Carbon tetrachloride. Carbon tetrachloride. So sometimes the question comes in the exam. Explain the process of manufacture of carbon tetrachloride. So remember to do this substitution reaction. Substitution reaction is the way of producing carbon tetrachloride. Coming to this is substitution, but this is the addition reaction. So this is an unsaturated hydrocarbon with oxygen. What it forms? It forms C2H4O2. So what exactly is this compound? This is CH3COOH. So CH3COOH. So this compound as well as this one is ethanoic acid. This is the addition reaction, addition of oxygen. Coming to oxidation reaction. So we have discussed about addition of oxygen. So now coming to oxidation reaction. What is the meaning of oxidation reaction? A reaction in which oxygen is added and hydrogen is removed. And here, how to convert alcohol to carboxylic acid. So for this, alcohol, so ethanol, CH3CH2OH. Ethanol in presence of alkaline potassium permanganate, KMnO4, or acidified potassium dichromate, K2Cr2O7, on heating gets converted to, that means that adds oxygen and becomes ethanoic acid, means CH3COOH and water. So this is oxidation reaction. That means alcohol oxidizes to become acid. So this is ethanol. Ethanol is IUPAC name, and this is ethanoic acid. Ethanoic acid. Okay. Coming to the next question, very important question. A mixture of oxygen and ethine is burned for welding. Can you tell why a mixture of ethine and air is not used? Remember, ethine is unsaturated hydrocarbon. Unsaturated hydrocarbon, when they are heated to their ignition temperature in presence of air, they burn with a sooty flame. They burn with sooty flame. And if soot means carbon deposits come, then welding is not possible. For welding, high temperature is wanted. And high temperature is attained when the flame burns with a blue flame, because the blue part of the flame has high temperature. So that is why it should be supplied with oxygen. How does ethine looks like? Ethine is this. This is ethine. Ethine plus oxygen. It gives carbon dioxide, water, and heat energy. And this heat energy will do the welding work. Discuss the test for saturated and unsaturated hydrocarbons. So there can be two tests. Either you burn them. If you see sooty flame, it is unsaturated. If you see blue flame, it is saturated. Or the bromine water test. The bromine water test. So what is bromine water test? Bromine water test is for unsaturated hydrocarbons like when ethene, that is CH2 double bond CH2, is mixed with bromine water, okay, it forms BrCH CHBr. Its name is 1,2-dibromo ethane. CH2 remains. Why? Because only one bond is broken. That bond contributes one electron to both carbon atoms which hold the bromide ion, ethane. The next one, alkyne, that is C2H2 with bromine water. This gives Br2 CH Br2. Name of the compound is 1122 tetrabromo tetrabromo ethane. So unsaturated hydrocarbon gets converted to saturated hydrocarbon. Rated hydrocarbon. And here this is brown color bromine water. Brown color bromine water. Here bromine water is decolorized. Bromine water is decolorized. Bromine water is decolorized. So properties and uses. So let's first discuss about the uses of ethanol. So ethanol uses, it is for medicine purpose, like it is used in cough syrups. It is used in antiseptics like tincture iodine. Then it is mixed with CH3 CH2OH, that is mixed with, this is the drinkable form, this is the drinkable form of alcohol, that is mixed with CH3OH, that means methanol. The undrinkable form means a toxic one, and that is called denatured alcohol. Denatured alcohol, it is mixed with copper sulfate to give it a blue colored liquid for industrial purpose. So these are the uses of ethanol. What are the properties? There are 4 properties. That first, ethanol properties, we can do it with equation. So ethanol plus metal. What happens when ethanol or any metal reacts with sodium? Then ethanol, not null, it's ethanol plus sodium carbonate or sodium bicarbonate. It's no reaction, remember this. So here reaction occurs, I'll tell what reaction, but here no reaction. So ethanol with sodium bicarbonate also no reaction. Ethanol plus concentrated H2SO4. It is a dehydration reaction, so this reaction is possible. Then ethanol in presence of alkaline potassium permanganate KMnO4, that forms ethanoic acid oxidation reaction. Then ethanol with ethanoic acid, ethanol with ethanoic acid gives ester in presence of acid catalyst. Gives so these are the properties of ethanol. So properties of ethanol, these uses, of course, you saw. Now these are the properties of ethanol. So the first one is ethanol plus sodium. This reaction is very similar to what happens when a metal reacts with acid. The same thing happens when metal reacts with alcohol. Metal plus alcohol is a salt plus a hydrogen gas. So exactly what it gives? It gives CH3, CH2O, Na and hydrogen gas. What is this compound called? It is called sodium ethoxide. It is called sodium ethoxide. What about the second one? Second one, okay, that's fine. The second one is called a dehydration reaction. Dehydration reaction. Why? Because there is concentrated sulfuric acid and in presence of 443 degree Kelvin. So alcohol on a dehydration gives alkene and water. We have to remember 443 Kelvin temperature. So this becomes CH2 double bond CH2 and it gives water. That is dehydration reaction. The third one is oxidation reaction. It is oxidation reaction. Oxidation reaction of alcohol gives carboxylic acid. So this gives CH3, COOH, ethanoic acid, then this is ethene, okay, and water is formed. Okay, so these are the properties of ethane. Properties means reactions. What happens when ethanol reacts with ethanoic acid in presence of acid catalyst? What is acid catalyst? Concentrated sulfuric acid. It gives, you see, this hydrogen and this hydroxyl will form water and the compound is CH3, COO, C2H5 and water. And this reaction is called esterification. Esterification reaction. A reaction in which ester is formed. So this is ester. This compound is ester because COO group is called the ester group. A sweet smelling substance used in foods, used in sweet smelling substances. Okay. Name of this is ethanoate. Ethyl ethanoate. Okay. Coming to the next question, why ethanoic acid is called glacial acetic acid? Ethanoic acid is called glacial acetic acid. Why? Because ethanoic acid freezes. Ethanoic acid freezes at approximately 290 degree Kelvin temperature. So it is called glacial acetic acid. What is vinegar? Vinegar is a 5 to 8%. Vinegar is 5 to 8% of ethanoic acid, CH3COOH, in water. It is sour in taste. I forgot to tell you one point. Ethanol has a burning taste. Okay. Coming to this, these are the properties of ethanoic acid. So these are properties of ethanoic acid. So whichever names we know, we will name them. So properties of ethanoic acid. So ethanoic acid plus ethanol in presence of acid catalyst, this reaction is called esterification. Esterification reaction. So here this hydrogen and this hydroxyl becomes water and we get CH3, COO, C2H5 and H2O. This compound is ethyl ethanoate. The next reaction is the ester, ethyl ethanoate with sodium hydroxide. This reaction is called saponification. Saponification reaction. What is saponification reaction? Here, C2H5 will combine with OH to form ethyl alcohol and sodium will attach to this, CH3OO. CH3OO, which is a negative, sodium is positive. So you get sodium ethanoate and ethanol, C2H5OH. So name of the compound, it is a salt and alcohol. This is called sodium. It is called sodium ethanoate. Sodium ethanoate, and this is ethanol. Ethanol. The next one, it is ethanoic acid and sodium hydroxide. It's a weak acid and strong base. Weak acid and strong base. Acid plus base is called a neutralization. So this is neutralization reaction. This will give salt and water. Because acid is weak, base is strong, the salt is basic salt. Name of the salt is CH3COONA and water. So it is basic salt. It is basic salt. Okay. Then ethanoic acid and sodium carbonate. Ethanoic acid with sodium bicarbonate. Here some point I want to mention that CH3CH2OH means alcohol plus sodium carbonate or sodium bicarbonate. This is no reaction. No reaction. So sometimes the question comes, what is the test to differentiate alcohol with acid, ethanoic acid and ethanol? The test is ethanoic acid reacts with sodium carbonate, sodium bicarbonate to give carbon dioxide and water, but ethanol doesn't react with sodium carbonate or sodium bicarbonate. So here this reaction, what happens when these two react, we get this gives CH3COONA, carbon dioxide and water. So effervescence will be seen. So sometimes the question comes, ethanoic acid with sodium carbonate gives effervescence. Name, identify the gas. Effervescence means carbon dioxide. Though hydrogen gas is also bubbles, but that's not effervescence. They are gas bubbles that burn with pop sound. Here effervescence comes. In this case also CH3COONA plus carbon dioxide, effervescence and water. Okay, so here the last three is the difference between ethanoic acid and ethanol. How you differentiate? You taste them. One has burning taste, another has a sour taste. Ethanoic acid is sour in taste. Okay. We are coming to the last part of the chapter, and that is what is a soap and saponification. So first I mentioned about saponification, then I'll talk about soap. So what is saponification? Saponification is making of soap. So I just want to start with a little bit before, where ester is formed, and ester with sodium hydroxide gives a soap. So first let's prepare ester, that is ethanoic acid plus ethanol, C2H5OH, in presence of acid catalyst, gives CH3COO, C2H5. This is ethyl ethanoate and water. So this ester is going to help us in soap making, that is CH3COO, C2H5. It reacts with sodium hydroxide, and on heating we get CH3COONA. This is a soap molecule. This is a sodium ethanoate. Sodium ethanoate is soap molecule, which is a salt. Sodium ethanoate. Ethanoate plus C2H5, that is ethanol. Okay. This reaction is called saponification. Now, what is a soap? Soap is a molecule. How does the molecule of soap look like? The molecule of soap looks like this. It will have a tail and a head. Head is actually the sodium ion, the positive one. Tail is actually the ethanoate, that is CH3COO negative one. This is how the soap molecule look. The tail is hydrophobic. Hydrophobic means water hating, and head is hydrophilic, means water loving. Hydrophilic. Okay, so hydrophobic and hydrophilic. How do we define soap? Soap is the sodium. This is the definition. Sodium or potassium. Sodium or potassium salt. Sodium or potassium salt of long chains or higher fatty acids or carboxylic acids. Fatty acids. This is how we define a soap. So sodium or potassium salt of long chain fatty acids is called a soap. So that's how the soap molecule look like. Okay, how to prepare soap? So let me scroll. If I have a space for soap, I do it. Otherwise, after scum, I'll be explaining that. So yeah, I just do it here. Okay, so I'll come to the topic scum as soon as I finish soap. So how soap helps us in cleaning purpose? So soap plus water. Soap, when it is mixed with water, actually soap will only mix in polar solvent, not in any other substance. Okay. So when it is mixed in water, it forms a cluster. It forms a cluster of soap molecules. That cluster of soap molecules is called a micelle. So when soap is mixed with water, when it is applied to oily dirt, so this is the oily dirt, oil. So the soap molecules tail will attach to the oily dirt because that is hydrophobic but oil loving, and the positive ion will be outside. So like this, the soap molecules connect by tail to the oily dirt. And here what happens, all the heads of the soap molecule are positively charged, so they'll have lot of repulsion. As a result, a perfect sphere is achieved because no two sodium ions would like to come close to each other. As a result, a perfect sphere of soap molecule where the tail is already connected to the oily dirt. So like this, a cluster is formed, and this is called a micelle. This is a micelle. Now, because the oil is well held by the tail, a little jerk is enough to remove or detach the oil from the oily surface or dirty surface. A little jerk can separate the oily dirt from the surface, from the murky or a dirty surface. This is how cleaning is done. Okay. Now I'm just writing a better saponification reaction. So this will be the better one, saponification reaction. So soap is saponification, or soap is the sodium or potassium salt of long chain carboxylic acid. So it is something like C17H35, 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 COO, CH2. And long chains of carboxylic acid means it will be like this only. So C17H35, COO, that's the connection, C17H35, COO. So this is the ester that is connected, that is reacted with a base. This gives C17H35, COO, Na, three molecules of this, and CH2OH, CH2OH, further CH2OH. This is alcohol, otherwise glycerol. Glycerol. And this one is soap. Okay. So this is the real reaction of soap. Coming to detergents. Soap is environmental friendly. So what about detergents? We have a difference between soaps and detergents. So you can write definition in either columns. Detergents. What are detergents? Detergents are sodium and potassium salt of long chain sulfonic acids. Sulfonic acids. So these are unsaturated compounds and not eco-friendly, unsaturated. Soap is saturated. Detergents are unsaturated compounds. So not environmental friendly. How does they look like? They look like something like ester. Okay. So unsaturated, so let's avoid the compound, but this is how it looks like. Not eco-friendly, but soap is a carboxylic acid, long chain carboxylic acid. Detergent is long chain sulfonic acid. Soap is saturated, this is unsaturated, eco-friendly, not eco-friendly. Right. Coming to scum. What is a scum? Scum is when soaps and detergents, they are mixed with water and applied on dirty surface, then they do the cleaning. Sometimes water may be hard water. So what is hard water? Hard water is something that we get from bore wells, or water that is locked between rocks. They are rich in minerals. So hard water contain, or it has a rich supply of calcium ions or magnesium ions. These rich mineral deposits that makes the water hard. Hard water do not foam, or they do not produce micelles. When micelle is not formed, that cleaning is not done. So what is a scum? Scum is like soap. See, ester, I start from here. Ester is CH3, COO, C2H5. When it is treated with sodium hydroxide, this gives CH3, COO, Na. This is soap, right? And alcohol, C2H5OH. Okay, done. When soap is treated with hard water, that means we are not using the tap water. Tap water is soft water. Good cleaning is done with the tap water. But when soap is used with hard water has got calcium ions or magnesium ions. So what happens? Calcium and magnesium will displace the sodium from the soap molecule. That finally gives CH3COO Ca or Mg. And sodium metal is displaced. This compound is greasy kind of soapy or kind of oily kind of dirt. Okay, greasy or oily substance called a scum. Substance called scum. The scum further makes the clothes dirty. Scum, this further makes the clothes dirty. Makes the clothes or surfaces dirty. So, to make a soap to work in hard water has to be first boiled so that the scales of that extra concentrated minerals like calcium and magnesium are separated. Then it is used, or more amount of soap has to be used for the soap to function. So that completes the carbon compounds chapter. So you have to sometimes rewind it, make it slow, and this will be a complete one round uh, kind of discussion on the chapter carbon and its compounds. Hope this video is useful for your any quick exam preparation. So best wishes, all the best. Ah, yeah, did I miss something? Yeah, we missed. Okay, that sulfur we'll do in the other chapter. So that was carbon compounds. And thanks for watching this video.